I have this huge midterm coming up, and I have no idea what's going on. All I know is that it's on excitation, contraction, coupling.
I took that class. I mean, maybe we could help you, because I know how stressful it could be.
That would actually be awesome.
Yeah, man, we'll explain it to you, no problem.
Jay, it's fine, what's up with you?
Okay, let me explain. Alright, Joven, so the first step is easy to correlate to the elevator ride. You see here, the nerve impulse is the floor number outside the elevator, telling the people, which are the ACH, to get on. After they board the elevator, they go down the elevator shaft, and the elevator goes down the shaft with the people inside, similar to the ACH, being transported to the synaptic terminal, which you can see right here. When the elevator reaches its destination, the ACH is released and goes down the transverse tubules. Does that make sense?
Yeah, it makes sense now. Thank you. What's the next step?
Yeah, when Emily gets back, she'll let you know about that.
You see, Joven, after the ACH has traveled through the neuromuscular junction, it begins to travel through the transverse tubule. You can imagine the transverse tubule as a long hallway, with the ACH molecules being a group of people. This is where the ACH binding sites are on the sarcolemma. The sarcolemma is the wall on either side of the hallway or transverse tubule. The binding sites are the doors along the hallway. Each ACH molecule binds the receptor on the sarcolemma. If the stimulus is great enough, an action potential along the sarcolemma can be.
Sweet, that's awesome. What else?
I think I can spin off the next step. Okay, so basically, sarcoplasmic reticulum is standing with balloons, which represents calcium. Sarcoplasmic reticulum loves ice cream, otherwise known as action potential. Acetylcholine comes from the opposite way with ice cream in hand, which represents action potential. If there is a large amount of ice cream, the sarcoplasmic reticulum will release the balloons, meaning there would be a release of calcium.
Okay, that sounds simple enough. Okay, so now that we went through the first 3 steps, now what?
I think I got this one. So this is actin, and it has myosin sites on it, but it's covered by the tropomyosin, which is the green. And it's twisted on top of those myosin sites because of the troponin, which is represented by these white gummies.
Yep. So then we have actin. We also have myosin, which is represented like this. The heads are already pivoted, waiting to attach to the myosin binding sites on actin. That can only happen if we have calcium that's released down, attaching to troponin. Once that happens, troponin shifts its shape, the tropomyosin opens up, allowing the myosin and actin to attach.
Wow, seems pretty cool. So now that I understand what allows actin and myosin to attach, now that actin and myosin have binded, what's next?
So next is how it all ends. This is the contraction phase. So you just need to remember, because this is tricky, that the myosin head attaches to the actin binding site. When this happens, ATP is hydrolyzed and they become ADP. When ADP and PI are released, they cause the power stroke. So keep in mind that the myosin head deattaches from the actin binding site only when calcium is no longer present. Once this happens, you could go right through the cycle again and everything goes again.
Say what?
I have a great idea with a visual. Alright, so take this stable gun I was using earlier. Imagine the handle is actin, base is myosin. So then, as I press down on the handle, there's going to be calcium ions binded to it. So that as it moves closer to the myosin base, there's going at the point of maximum excitation, there's going to be a force production. So then, as that force production occurs, as the handle goes back, imagine that's actin coiling away from myosin. The calcium ions will then be released into the sarcoplasmic reticulum. Once the handle has been fully extended, imagine that it's actin in its original state, and tropomyosin will no longer be blocking the binding sites. And that's all there is to excitation, contraction, coupling. Pretty cool, huh?
Yeah, that's awesome. Thank you guys.
You're welcome.
You're welcome.